Hello everyone, welcome back. So today we are going to solve a new question which is n meetings in one room. Okay, so this is a this is not a lead code problem, but it is a geeks for geeks problem. Means and the difficulty level is easy. Okay, here you can see that the difficulty level is easy, but so then why I am solving it, like if you see the accuracy, so it's almost 45.3%, so the accuracy is pretty low. And I think this is very important to understand the greedy algorithm. That's why I am making this video, and I think it will be helpful. So let's understand the question. So there will be two array. One will be that where the meetings will be start, and one where the meeting will get ended. Okay, so if we see this array, so one meeting is going to start at 1 o'clock, suppose 1 o'clock, and it will get ended uh, at 2 o'clock. Okay, in this way we have to, and we have a meeting room, and only one meeting can be happen at the time. Only one meeting can be held in one meeting room at a particular time. Okay, and we have one meeting room, and so this is the this is the question. And the meeting, the starting time should be greater than of ending time. Okay, let's suppose we have a yeah, here we have suppose 5. Okay, and here this is not mentioned. If the ending time is also 5, then we cannot take the meeting. Okay, so in particularly in greedy approaching, if we sort the um, starting array, then we will see that it will take 0 index first. Okay, so 0 and 0, which is equal to 6, so it will, the meeting will be held for 6 hours. So in sorting of the start array, we will not get the optimal answer or global optimal answer for this particular question. But if we solve it using the ending time, and we take the ending times which are which have the lowest ending time, then we can solve it. Let's see how. Okay, so I am going to code it now. So first of all, we are going to start with normal proceeding, like is going to have the integer n, which will be start. You can take anyone because both are same. Start of start size. Okay, and now we will have a pair type data structure. Okay, where we will store the starting and ending time in a vector. Okay, so it will be pair vector of pairs. Okay, vector pair, and it will int, and it will linear. And suppose we are giving the number is the name is timer. Okay, timer. Now what we will do, we will simply do a for loop where we will put the start times and ending times in the timer vector. Okay, so there will be for loop for for int I is equal to 0, yeah, I less than n, because n is the maximum number of the size of the starting or ending array. I plus plus, what we will push timer dot, or let's say it is meeting time. Okay, timer is very confusing. Meeting time. Okay, so meeting time dot push back. What will push back? Start of I and end of I, right? So start of I and end of I. Okay, we will push it. So in the array, we in the vector we are having start I and end I. Okay, let's see. Now we are going to sort it, okay, but sort on the basis of the endings, right? So if we want to sort it with the basis of the ending, we have a different approach, which is comp function we have to use, right? So let's see. So we will sort it, and it will be meeting time dot begin, comma, meeting time dot end, and there will be com, because we need to sort it using the using the ending array. Okay, not the by default it will sort using the starting array. It will take the starting array and it will sort, but we are trying to use the ending array, right? So let's write the comp. So this will be a bool function, okay, bool conf, and it will take two arguments. One is pair int comma int, suppose it is a, and pair int suppose it is b. Okay, and what it will return? It will return simply if it is okay, a dot second less than b dot second, then it will return yes, otherwise it will swap. Okay, so this is the code. Okay, now it's very simple. So we have a sorted vector array, vector pair array, whatever meeting time, where we have the meeting times, meeting ending times in a sorted array. In this case the array is already sorted, so you can see that. So, okay, now we will take every endings one, and if we see that ending one is less than the starting one, okay, starting one from here, if we see, then we can say that yeah, that meeting can be done, and we will increase our total count. Okay, so in total we have to have total is equal to 0. Okay, and the ending time, suppose the ending will be int max, okay, or mean, whatever, int mean, okay, or take like -1. Okay, that this will also work, because there is no -1 here. Okay, so now there will be simple for loop. Okay, for int I is equal to 0, I less than of n, simple, and I plus plus. What we will check? We will check one condition here. If timer of I dot fast, right? Because the fast time should be greater than the ending time, right? So it should be less than the greater than the ending time, because it is already said here that the start time of one chosen meeting cannot be equal to the end time of the other chosen meeting. Okay, so it's obvious that we have to take the greater than sign, not a greater than equal to sign. Now it is simple. If it's happened, then we will do total plus plus. Okay, total plus plus, and we will make sure that ending time gets updated, like, right? So in ending will be like timer, ending will be timer meeting time. Okay, meeting time it was, That's a mistake because I was thinking about timer. Sorry. So meeting time. So meeting time of I dot second. Okay, this will be our condition. Okay, we'll change the ending time to -1. Now just return the total and I think it will work. Okay, sorry, return total. Let's see if it works or not. Okay, there is some problem, I think. Okay, okay, so yeah, there is a problem. Okay, sorry. Yeah, it's completely working, as you can see. Okay, and now if we submit it, let's see what's happened. Yeah, it successfully passed all the test cases. So it's very simple and you only need to have a good understanding about the STL and this pair vector, these things, and otherwise this code is very simple and it is a basic, but will make a base of greedy algorithms. Thank you.